Hello everyone, my name is Zahra, and for the next 15 minutes I'm gonna talk about our massive Persian Quenstion-Answering and Chatbot Dataset, aka PeQa. Motivation. It may not be a popular opinion, but I think the technology has always been driven by money. There are many applications for chatbots, but the one that made it this widespread is actually customer support service, since it has a direct impact on financial benefits of companies, either by increasing the rate of answering to the incoming queries or by reducing the number of staffs. As you can see in this slide, of course, there are other applications such as education, search engines, data analytics, etc. But the point is that we need chatbots, and to train them, we need a good dataset, which we provided. Table of content. In this presentation, I would like to have an introduction about the question answering system and chatbots. And next, we will go through the related works briefly, of course, especially the most famous available open domain question-answer datasets, both in English and Persian. Next, the most important part is our dataset. We will analyze and introduce our dataset in both linguistic and statistic aspects. And then at the end, I would like to show the results of using this dataset to train a chatbot. Introduction. What's a question-answering system? Well, I don't think the question-answering system needs that much of introduction or definition, but as the name suggests, it's a model that can retrieve or generate an answer to a given question. Such model usually consists of three components: the query processing module, the document processing module, which is to get the information from the text, and at last the answer processing module. What's the difference between a question-answering system and a chatbot? I firmly believe that there is actually a slight difference between a chatbot system and a question-answering system, although these two systems have some similarities and even sometimes considered the same. But conversational question-answering systems should be able to interpret a question accurately, considering the context of an ongoing conversation to provide a relevant answer. And beside the relevance, it also needs to be correct. For example, I can ask the system which day is today, and it answers it's Monday. It is rational and it is relevant, but today is actually Sunday. So the rationality alone is not enough for a question-answering system. On the other hand, for the chatbots, the most important thing is to keep a track of conversation and even save and record some previous dialogues to refer to later. The correctness of answers in chatbots is not that critical, since unlike question-answering system, a chatbot can make a joke. Like, you can ask it, where are you? And it answers everywhere. It's not actually a correct answer, but it will fulfill the chatbot duties. In this slide, you can see 4 core differences of question-answering system and chatbot, which are technology, core functionality, channels, and interface. And I would like to highlight the difference between channels and interface. Interface is actually the way that you, as a human, communicate with your chatbots or question-answering system, anyway, which can be like voice commands or text, anything. But channels are actually the platform that you implemented your model on. Well, you know, this dataset we created and presented is a large Persian dataset of text and answers. I'm using the text phrase instead of question because the text we are seeking an answer for is not necessarily a question. It can be a piece of human dialogue, whatever it is, that requires a response, or even it can be a command. As a result, this dataset can be used for both chatbot systems and question answering systems. And you know, it's extracted from the Twitter, and you know how Persian Twitter is. It has everything in it, including jokes, political analyses, recommendations, sport picks, and such. And people in Twitter are either making fun of something or arguing about the piece of news. Anyway, since this dataset can be used in both question answering and chatbot, as the related works here, we only listed the open domain datasets. Actually, there are many datasets for question answering in English, both open domain and topic specific. And you can see the most famous one in this slide. Also, this PeQa, I don't know actually how to exactly pronounce it. It's also a very good example of conversational question answering dataset in Persian, which I think is also the first one in Persian as well. But the point is, look at the number of question and answer pairs in each dataset. We actually managed to collect a total of 14 million pairs, which is indeed a huge dataset. That's the key difference between our dataset and the previous ones. In this slide, you can see the statistics analysis. As I just mentioned, there is a total of 14 million pairs of question and answers from 60,000 Twitter users, and 300,000 of this data is cleaned and published for free. You may ask why only this amount. That's because you know how cleaning and making data usable is hard, and it requires both time and manpower. Still, you can access also the raw data if you want to. And at the left side of this slide, you can see the word count and data count as well. About the linguistic analytics, first is data source. I mentioned several times that the data source is Twitter. And Twitter is a social network where users can share messages with a limited number of characters. Most of the social medias have this limitation, but the text content of a tweet can only be, I think, up to 200 characters or so. Anyway, Twitter is a rich source of people conversation, covering a wide variety of topics, which is totally suitable for an open domain question answering dataset. And the other one is about the language characteristics. Tweets are highly influenced by characteristics of informal language, which means the data also includes widely used foreign phrases, especially phrases in English and Arabic like okay and inshallah. Also, unfortunately, some people do have this bad habit of writing Persian words using English characters, which is called Finglish. And we had two options to address this issue. We could either convert this kind of sentences into formal Persian, or we could remove them. Of course, we chose to remove them entirely since we were too lazy to do so, and it was time-consuming. It was actually a waste of time. But the good news is that since we collected tweeters from just some selected users, we managed to avoid this problem as much as possible. The next one is about the sentences type. Normally, a question-answer dataset is obviously pairs of question and answers. I mentioned that the questions in our dataset is not always actually an actual question, but except for that, I would like to formally announce that even our answers are not always an answer. I mean, you can see the question's answer with another question in this dataset, all thanks to the specific form of conversation in Twitter. The next one is about politeness, and by politeness I don't mean curses and nasty words in the tweets. Unfortunately, you can see many of them in social medias nowadays, but we tried to keep them as long as they were not that insulting. But by politeness, I mean the pronouns we use to address someone formally. Like, we can use shoma instead of to in Persian. Nearly the half of data in our dataset is in this formal form, but we know that actually the ratio of usage of this formal language in people's daily conversation is not that much. This is an effect of using that seed of selected users as well. It increased the politeness. And the last one is data quality assurance. The text of tweets includes redundant items, such as emojis, links, hashtags, which are not required, obviously, so we removed them. In this slide, you can see the top frequent words, both in question and answers, as an example. And just by looking at it, you can see how familiar these words are, since they are actually the words we use in our daily conversation every day. Model benchmarking. To train the model with limited number of data tokens, so the first 5,000 frequent tokens were selected, and after extracting the top frequent tokens, the tweets that are made only from these tokens extracted to be fed into the model. So we only used this part of data to train our model, and our model is actually a transformer model as the test bench model for the question answering problem. You can see the transformer model architecture at the left side of the slide here. And about the results, well, I should mention that the criterion we use this SSA, which used to evaluate the generated answers. However, being rational is not enough. We talked about it before. So a neutral answer, like I don't know, which you can see in the slide, can be rational, but it's so robotic and boring. So you can see some examples of generated answers by the model. And at this point, our model kind of looked like a bad-tempered person. How did we fix that? Easy. We actually increased the number of tokens. I talked about the selection of the tokens. We increased it to 10,000, which meant about 400 pairs of data. And you can see the results in this slide. As you can see, the answers look more specific. They are still short though, but it's because the average of words per sentence in our dataset is only 3.7, and that's because tweets are mostly short. We talked about the limitation of the character in a tweet. So any rational answer more than 3 words looks good to me. Well, I talked a bit about the evaluation, but to be more specific, we had 5 evaluators scored each responses according to SSA criterion. So you can see a few examples here, which are generated answers and their scores in the leftmost column. And this column is actually the average of all evaluated scores. In this slide, you can see the summarized results that I explained about so far, and it perfectly shows the relation of data size and accuracy. If just doubling data size can have such impact, imagine what would 14 million pairs of data do. That kind of show how good this dataset is. Conclusion. Well, we presented a very large question-answering dataset extracted from Twitter, and it's highly comparable with the daily human conversations. It is accessible for free, and a part of it is cleaned even. We just hope that this dataset can help researchers with their question-answering system and chatbot models. Okay, I really appreciate the attention, and if there's any question, I would be more than happy to answer. You can also reach out to me using my email address here. That's it. Thank you.